right? So this three examples, so all of them are in terms of piecewise function. As I told you before, that is the most common. So for the first one, I have a function f of t called t and negative t. So we're going to sketch this, what do you call that, piece by piece according to what we have. I'm going to start with the first one, so which is going to be t is equal -1, and is it going to equal t from -1 until 0. So here, let me put the axis first. So I'm going to have -1 somewhere over here. So what I'm going to do is I'm going to use the same trick that I've shown you before. So when t, I'm going to take the lowest and the highest value. So when t is equal 0, when I substitute into the equation, so I'm going to substitute right there. So of course my f of t is also going to equal 0, because f of t is equal t. And then when my, t is equal -1, okay, so I just take these two values. So my f of t is also going to equal -1. So those are going to be my coordinates. My coordinates is going to be 0, 0, and also -1, -1. So just roughly put on your sketching where it's going to be -1. Let's say I'm going to put it over here. Okay, and because this is t to the power of 1, remember, if you have an equation with x to the power of 1, so y equal mx plus c x to the power of 1, this is going to be a straight line. So that is why all you have to do is connect these two in a straight line. So that is going to be my first function. F of t is going to equal t from -1 until 0. So now I'm going to do the same thing for the second function. And now the second function is going to be this one, that my f of t is going to equal -t from 0 until 1. So it's going to be the same trick as before. So when my t is equal 0, my f of t is going to equal negative of that, which is still going to be 0. And when my t value is equal 1, so f of t is going to equal, substitute right there, so it's going to equal negative of 1. So the coordinate is going to be 0, 0, and the other one is going to be 1, -1. So let's say 1 is going to be somewhere over here. So -1 is going to be down there again, because this is t to the power of 1. So it's going to be a straight line. All you have to do is connect these two dots in a straight line. Okay, so that's how it looks like. And right after you have sketched the shape using the first function, you can tell right away so whether this function is even, odd, or neither. So if you notice right here, so both of them are actually side by side. So straight away we can tell that this is going to be an even function. Okay, however, do not leave it like this. So when we sketch a periodic function, there is not only going to be one cycle, there will be multiple cycles. And how do we know how many cycles should we sketch? That is going to be based from these values given right there. So you have to be sketching your graph from -3 until 3. So therefore, let's extend this. So let's say this is going to be -2 and -3. So this is 1, 2, and 3. Remember what I've shown to you before? So the fact that the idea is going to be copy and paste. So I'm going to copy this particular shape right here. I'm going to imitate this shape right here. And what I'm going to do is I'm going to put it on the other side. And I know that from what's given in the function right here, that the period value, it is going to equal 2. So meaning that every 2 units distant, that it is going to be a new cycle. And where is the 2 units distance? So I'm referring to this one. So from -1 to 1, so that is 2 units distant, that is going to be one cycle. From 1 until 3, there's supposed to be another cycle. And from -1 until -3, I'm going to end up with another cycle. Now let's imitate the shape. If you notice, the general shape is just a triangle that looks like this. Now all you have to do is just imitate the triangle. So now on this side, I'm going to have another triangle, another cycle. And on this side is also going to be another triangle, which is another cycle. So basically that is going to be our periodic function. So it's a very simple idea. Okay, but you have to be very careful, because this is going to determine whether the calculation is right or wrong. Okay, and for the first one, it's going to be an example of even function. So let's have a look at the second one. So the idea is going to be still similar. And for the second one, so we're going to be sketching this from an interval from -3 pi to 3 pi. So I'm going to have here, like, put the scale first. Okay, and the scale, you know, like, it doesn't have to be always 1, 2, 3. What if, like, you have to sketch from, for example, 0 until 20? It's not like you're going to draw 1, 2, 3 until you get a value of 20. it has to suit your scale. For example, if you can actually sketch it in terms of 2, 4, and 6, so put it in terms of 2, 4, and 6. So be creative with this. Okay, but for mine, because I just need from negative 3 pi to 3 pi, so I'm just going to put like 1 pi for each scale right here. So this is going to be pi, 2 pi, 3 pi, and this is going to be negative pi, negative 2 pi, and on this side I'm going to have negative 3 pi. So now let's start sketching the primary shape. Okay, so the first function that I'm going to use is going to be the top one. So f of t is going to equal t plus pi. So I'm going to substitute t right there with values of negative pi and 0. So now when I substitute t equal negative pi in here, so I'm going to get a coordinate of, so the first one is going to be negative pi. So negative pi plus pi, that is going to be a 0. So negative pi 0 is going to be right on the t-axis. And then I'm going to substitute the highest value 0. So when my t is equal 0, 0 plus pi, that is going to equal pi. So 0 pi, let's say, is going to be somewhere at the top right here. So again, this is t to the power of 1. So just connect these two dots in a straight line. So that is how my line t plus pi from negative pi to 0 looks like. And I'm going to do the same for the second function. So I have t minus pi with the lowest value 0 and highest value is going to equal pi. So I'm going to use exactly the same method. So first I substitute when t is equal 0. So when I substitute in here, 0 minus pi, that is going to equal negative pi. So 0 negative pi, let's say it's going to be somewhere down here. And then when I substitute t equal pi, so into the equation, pi minus pi, that is going to equal 0. So pi 0 is going to be right on the axis. Again, this is t to the power of 1 straight line. So I just connect this two. Right away from here, we can tell what kind of shape is this, right? So I have 1 at the top, 1 at the bottom. And if I were to reflect this, I will end up with something like this. I reflect that again, only I get the second line, okay? And that is why this is a characteristic of an odd function. Straight away, I can take that this is supposed to be odd. Alright, and again, as I mentioned to you just now, do not leave your graph like this. This is not done yet. So this is just one cycle. So from here, we know that the value of the period is going to equal 2 pi. So meaning that every 2 pi distance, so that is going to be another cycle. So it doesn't necessarily be always 3 cycles. It's because of this example. I make it into 3. But usually it could be 2 cycles. It could be 3, it could be 4. So it depends on the question itself. So if you notice, what is the primary shape of this? So this is, you have to be very careful about this. So the primary shape is going to look like somehow like a kite. So it's going to look like this and like that. So that is our primary shape. One line at the top, one at the bottom. So when I imitate this, so I'm going to have again one line at the top, one line at the bottom. So one line at the top, one at the bottom. So that is how the graph looks like. Okay, and please, when you write your lines, do not use dotted line. Do not use something like this. No. So your graph should be a solid line. Okay, it should not be a dotted line. You only use dotted line for cases like this. If you notice, at 2 pi, so it could be up here. It could also be down here. So for cases like this, I can actually draw a dotted line in between. So that is where you use dotted line, or simply just leave it as blank, like what I did previously. That's fine as well. So instead of having those dotted line, you can also cancel them. So it doesn't matter. If you have that or if you don't have that, so it doesn't affect your graph. Okay, but when you draw the function, put a solid line on that. Don't use dotted lines. Okay, so that is going to be for B and for C. So now I'm going to sketch the graph. This is going to be my interval. So it's going to be from negative pi until 3 pi. So let me put the scale first. So negative pi on this side. There goes my pi. And this is going to be 2 pi, and this is going to be 3 pi. Okay, so first of all, I'm going to start with the first function. So it's going to equal 0 from negative pi until 0. If you notice, this is actually a graph of a constant. If I write it in terms of y, this is a graph of just y equal 0. And we know that based on what we have discussed previously, on what I have shown you. So when we have a graph of a constant, so it means that the gradient is actually a value of 0. It's not going up, it's not going down, so it's going to be a horizontal line. So that is why for this case, I'm going to have a horizontal line at f of t equals 0. So where is f of t equals 0? So it's going to be right here. So this is where my f of t is equal 0. So let me draw that thicker so we can see that line. Okay, so it's just going to be a horizontal line with no gradient. It's not going up, it's not going down. And then I have a graph of t square from 0 until pi. If you remember, okay, this is going to be a bit tricky. If you remember, graph of f of t equal t square, this is actually the same as graph y equal x square. So we know that it's going to look like this. So this is the graph of y equal x square looks like, for which the intercept is going to be at 0. Okay, however, okay, we know that like if this is going to be pi, this is going to be pi square. If this is negative pi, sorry, it's going to be the other way around. This is pi, this is still going to be pi square, because we substitute right here. So when t is equal pi, so f of t is going to equal pi square. So that's why I have pi square at the top. But now we need this particular shape, but we only need this shape for certain interval, and the interval is going to be from 0 to pi. So where in this graph is the interval from 0 until pi? So it's going to be here. So this is where my 0 until pi is. So meaning by I don't need the shape on the other side. I only need this from 0 until pi. So that is what I want us to catch. My graph is going to look like this. And when t is equal pi, so my f of t is going to equal pi square. So that is how my graph looks like. So it's going to be a half of a t square. Alright, so based on what we have seen, so what kind of function is this? If I say that this is going to be an even function, so if I were to refer to this line right here, I should have this as my line if it's even, but that's not the case. If it's odd, so it would be still the same, like it's still going to be this line right here. Okay, so but it's definitely not going to be odd, because remember the features of odd is that you have one function at the top and one function at the bottom, like this. Okay, that is why for this case it doesn't exhibit both characteristic of being odd, it doesn't exhibit the characteristic of being even. Automatically it is going to be falls into the category of neither function. Okay, and what is the primary shape? This is the primary shape, a straight line and a curve. So that is why, because here our period function is given by 2 pi, I know that every 2 pi distance there is going to be a new cycle, right? So I know that on this side I'm going to have another shape of this. So it's going to be a straight line and a curve. So that's how my graph looks like, right? So actually sketching periodic function itself is going to give you 3 marks. Like you don't have to do much things, but you are being awarded 3 marks. So that is actually a good bargain in terms of like getting your marks. So you should be able to do this right. And of course, like we know that this is not going to be a straight line, because for this case my t is raised to the power of 2, and we know that graph to the power of 2, x to the power of 2, is going to be a quadratic graph, whether it's going to be concave up or concave down, whether it's positive or negative. Okay, so that is how you draw periodic function. So for my students, I'll provide you with exercise on sketching periodic function, and you will also have exercise for you to try in your book as well, and your lecturers might provide, if you're not from my section, and I'm pretty sure that your lecturers will provide you with exercise on this as well. Right, so try those, and remember, please catch them very carefully. It's very crucial. It's the most crucial part of your calculation, sketching the graph.